Hi, I'm John Paul Raj, and in this video, we're going to continue to solve question number 1 from paper 3, May 2025, IB Mathematics Applications and Interpretations, May 2025. This is the time zone 2. Let's get started. So in the last video, we ended at F part 1. F part 2, I did not complete for some reason. I don't know. It became too long, right? So let's just go to F part 2. It says, if the requirements are met, state an alternative test. All right. So what requirements are we talking about? If you want, you might want to just check the earlier video. I'll link it somewhere, or you can follow along on the playlist. Basically, the context, to give you a quick context, it says that Augustine wants to determine if there's evidence of any correlation. Now, from your syllabus, you know that you might have studied both the Pearson product moment correlation coefficient, which is what is being used here. I made a mention there, okay? But basically, he wants to know whether there's any correlation coefficient. So when it says assuming all requirements are met, we're talking about the requirements for the Pearson product correlation coefficient. So according to your theory, you know that, Pearson product, it's more of a linear relationship. So something to do with linearity has to be, met. That's one of the conditions, okay, for the Pearson product moment correlation coefficient. We're not using it directly, actually. We are just using the numbers that is given to us. So we just went with the critical value that is given to us and the value of R for the sample that they have claimed, right? Yeah, he says the Pearson product moment correlation coefficient between the results for the entry exam and the final exams were. So the values are given to us. We just compared the value from the sample, and the critical value at 5% was given to us as 0.576. This was done in the early video. So assuming all requirements are met, the Pearson product moment correlation coefficient was, used. But if the requirements are not met, what's the alternative? Spearman rank. Okay, so I'm just going to write it here. F part 2, we will use Spearman rank correlation coefficient, because that's the test, Spearman's ranks test. If you want to use that word test, you can use the word test there, okay? Because as you know from your theory that, the Pearson product moment correlation requires some kind of linearity. So it's more like to see whether the relationship between the two variables, two sets of data that you're comparing, is that a linear relationship? So if the data is not linear, or if it is, I think that's the main idea for Spearman rank. Those are the conditions. Probably we don't need to go through the conditions here, but this is just for your own theory, okay? Just to review your own theory, because Spearman uses ranked data. The data is being ranked, and rather than the monotonic. Monotonic means is it increasing, decreasing, linearity in the Pearson. That's just a little tip there, okay? Never mind. F part 2 is done. Let's move on. The examination board uses a model to make a prediction of the student's final exam result. So y hat is the prediction. Y hat is the prediction of the student's final exam result based on their entry exam result X. So there's an entry exam result X, and there's a predicted score y hat. Okay. The model uses this. So they've given you the equation. Y hat is given by that 0.37. So they're saying give in context an interpretation of the gradient 0.37. Well, this is a linear model, so you know that that's the gradient 0.37. So literally you can say that because X is the entry exam, so every 1 mark increase in the entry exam, the final exam result, which is y hat, will increase by 0.37 on an average. Okay, that's a good way to put it. Let me just write it down here. G. So question number 1, G. For the model y hat equals 0.37x plus 37.6, the gradient 0.37 means that for an increase of 1 mark in the final exam, in the student's final exam. No, that was the entry exam result. Okay, in the entry exam result X, the final exam result, of the student's final exam result, the student's final exam result on an average, always safe to say, use that phrase, will increase by 0.37. So for every 1 mark, 0.37, right? Or is it 371? 37, okay. So for every 1 mark increase in the entry exam, that's the data X, your Y hat, student's final exam result, that is Y hat, on an average will increase by 0.37, okay? All right, next, let's keep reading. For each student, Augustine uses the value Y minus Y hat, rounded to 1 decimal place to measure the extent to which a school helped to improve the student's results. What is the influence of the school? He calls this the school value added, this school value added. So this Y minus Y hat, this column out here is the school value added. This is the table 2. So you got your schools. I think the first 6 should be 1, 2, 3, 4, 5, 6. Yeah, the first 6 is from A and then the next 6 is from B. Exam, entry exam X, final exam Y, and this is the predicted, right? Make a prediction is this. Prediction is the formula, and this is the school value. So Y hat is not here. Y hat is to be used with the formula. I think that is what we'll have to use to find this Q, which is unknown here. Let me just check that. H, the next one. Show that the value of Q. Yeah, show that the value of Q is 0.6. So basically, we're just using the formula to find the value of Q given here with that model that's given. All right. So this is for 2 points. Calculator option. And I am just going to draw a line here, and this is 1H, and what do we have? This is for Q, right? We want the X, which is 38.7, 52.5, and so Y hat is for the first thing we need to find out. Let's just write down, okay? Y hat is going to be equal to 0.37. This substitution, you got to write it down, okay? So for the value of X, 38.7 is the corresponding value of X, 38.7. So this substituted expression you got to write, although you're going to use a calculator. 0.37 times X plus 37.6 plus 37.6, and then, you know, your Q should be just Y minus Y hat, that value of Y hat that you'll compute, and the value of Y here is 52.5, okay, 52.5. The value of Y hat you're going to compute in a minute, and let's just jump to the calculator as we say that. Okay, you can see the calculator nice and clean. All right, here we go, and I just hit enter. What do I have? 0.37, 37 multiplied by, what was that? 38.7, 38.7. And that's some value. You can add 37.6 to that result, and you get 51.9. So that's why I had 51.9. I'll just show you. Okay, I just set it up earlier on. Okay, I just set it up and then jump to the calculator. Okay, because I know many of us directly we jump into the calculator, but write it down. This is why I said every little thing that you write, is going to be counted as working. So now Y minus Y hat, that you can write it as 51 point, I'll just use the same color, 51.9, and this, when we do it on the calculator, you can say this is 52.5 minus that 51.9. I can just bring down as many digits as I can. I get 0.581, 0.581. That is my value of Q, and I think that's what they said. Oh, they just said find the value, right? 0.581. Okay, show that the value of 0.6 is, they said. Is it just 1 decimal place they want? Let me just check. Yeah, they said it's rounded to 1 decimal place, right? Yeah, can you see that? 1 decimal place. 1 decimal place. Okay, so this is 1 decimal place. So make sure that you round it up to 1 decimal place, and obviously that rounds off to, you can say 0.61 decimal place. Okay, that's cool. Now what? Next part. assuming that the appropriate requirements are met. Use a pooled t-test, again a pooled t-test, at a 5% significance level to determine if the mean school value added, okay, this one, the mean of this values is higher in school A than in school B. Wow. Determine your null and alternative hypothesis and justify your conclusion. 4 points for that. Okay, will we be able to complete this in this particular video? I have no idea how much time have you gone through. All right, let's just try it anyway. Okay, so let's try the null and the alternate hypothesis here first. Now this data is given. This time we are going to use the data entry. I think in the previous video when we did the pooled t-test, we used the stats. Okay, if you haven't watched that video, please go and see that we use the stats. So this time the data has to be entered. Okay, and it says that the mean value in A, the mean school value added in school A is greater than school B. So I think we're going to use the same notation, mu A, mu B, to justify that, or to write the hypothesis. This is H part 2. I'm going to just write it here. Okay, so this is question 1, H. Is it part 2 or part 1? Part 2. Okay, and I'll just write down pooled t-test. Okay, two sample pooled t-test. If you want to write that also, I'll just write it down anyway. 2 sample. Okay, H naught is going to be equal to mu A equals mu B, because you know what, the null, as we all know by now, it is just the status quo. That means there is no change, or yeah, they both are equal basically. The alternate is what's being claimed, right? So the claim is that, you know, determine if the mean school value added is high in school A than in school B. So when we write H1, the alternate hypothesis, we can write mu at A is greater than mu at B. And then since mu is something that we've introduced, I'd say, you know what, write down what that is. What I mean by that notation, that symbol is something that you've introduced in your answer. So good idea. You can write it down where mu A and mu B represent the mean. Let's use the same vocabulary. Mean school value added. Mean school value added mean school value added for school A and school B respectively. Okay, make sure that that is indicated clearly. All right, once we've done that, have you written the null and alternate? Okay, then what does it say? I done the null and justify conclusion. All right, so we got to just perform the test, but it's going to take some time to enter the data. Maybe you should just enter the data, right, and then pause the video or something like that. Shall I do that, or it just gets long? So yeah, let me just pause the video recording, and then I'll get back to you when I've entered the data. Or should I just continue? I don't know. Let me just continue, and if it gets long, then I'll edit it out. Okay, you'll understand what I mean. Okay, so I'll just put a text. I'll just go here. Typically it just gets long, and I want to make sure that it is done right. So this is my list and spreadsheet from before. I can use the same list and spreadsheet as long as I label it correctly. So at this point of time, if you see me jump through, it means I have, you know, paused and cut all the middle part. Okay, so I'm going to put list 1 and list 2 and list 3. List 2, by the way, will be the results for school A. All right, I'm talking about the school value added, just this column, this last column, this column. Okay, that's what we want to compare, right? So first for school A, the first 6 entries right up till here. Okay, right up till here. Okay, we are not talking this one, sorry, just this part. Okay, this part is going to be my list 2, and this is list 2, and this is going to be my list 3. Okay, just for your reference, I might cut that chunk off and you'll know what's going on, so that I don't know how many minutes I'm going to save by that at all. Okay, so let me just go 6.2. Q is something I just worked out as 0.6, I believe, 0.6 and 1.3 and negative 2.2, negative 1.5, 2.8, and that's all the entries here. Let's go to list 3. I got negative 3.4, negative 3.0, negative 9.9, wow. And then I got 1.2, I got negative 0.6, and I got a negative 5.1. Okay, so I've got those two sets of data. Now, this time, just, you know, as I said, you can run the test even from here, from the listen spreadsheet. Let's do that here. I think in the earlier part, we did the listen spreadsheet, the test, we ran it from here. Can you see that? That's still there, actually, by the way. Yeah, that was the t-test that we ran, right? 2 sample t-test, you know. There, the mu1, I think the mean for school A was less than, or that was the alternate, right? That we said that school B was greater. This time, I think we're saying that school A is greater. Okay, so let's just run the t-test from here. Statistics and start tests, and to sample t-test, be careful. Okay, and the method, remember this is data now. Last time it was stats, okay, if you recall that. And we say okay, and be careful where you're picking your list from. That's why it's good to label. List 1 is actually list 2 of mine, and list 2 is actually list 3. Okay, be careful how you're labeling that. You could have called it school A, school B. Frequency remains the same. Alternative hypothesis, we are saying that the mu1 should be greater than mu2. Okay, be careful with that part also. Pooled, we say yes. Results in column G, always TI gives 1 column extra. Okay, so I'll just say F, okay. The reason that is also important for those of you who don't know what this is. Okay, let me just highlight this properly so that I'm talking this part. Can you see that this part? Okay, this part, all right. Why is that important? Is because sometimes if you don't mention the correct column, it will override whatever's there in that column. It will overwrite that. Okay, so be careful, even that small thing, be careful. This one, I mean, you can try it out if you want. I just leave it blank. The reason I leave it blank is because, you know what, it does both of them in the same window, and it's a hassle trying to separate the two. But before we go any further, make sure that you copy down whatever you've entered. That's more important, okay? When you say using GDC, this is the most important thing. And this might look funny, list 1, list 2, because that's what I've called it. You might use a better column name like school A, school B, all right? But I'm going to call because that's what I've written there, okay? So jumping to my notes here, I'll just write down using GDC, and as always, how did I use GDC? I just mentioned that. Copying it from here, that this said to sample t-test, so that basically the examiner knows this is what you used and what the entries were like, you know. Not that they're going to come and check, but you know, it just supports the idea that you have literally, and because this is part of the same question, they'll know that, you know, list _1 was something that you used before, you know. So yeah, not that they are, yeah, frequency 1 is 1, frequency 2 is 2, alternate hypothesis is HA, and you can see we use H1. I think schools in the US, even if you're doing something like AP statistics, you know, HA is alternate, but that's all right. Pooled, we say yes. And what else is there? Is there anything else here? I don't think we need that first column 1. Okay, so this much is enough using GDC. Okay, let's jump back to the calculator, and we're just going to hit OK. And we'll see what it says. The p-val is 0.02. That's what we want, right? Because it said, what it said, 0.02. Let me just check this. 0.0213 I will take, okay, as the 3SF, okay? 0.213 is what I'm going to take. So I'm just going to come back. I think it just said, it says, write down your null and alternate hypothesis and justify conclusion. So we can say, I'll just justify here because this next question is starting here. Yeah, let me just go down anyway. So I just say p-val is, what is that, 0.0213. I say since p-val equals 0.0213 is less than 0.05, which is our significance level, significance level, there is sufficient evidence at the 5% significance level to reject the null hypothesis H naught. What was the rejection we are talking about? That, you know, the mean school value added is the same, and now we're saying that, you know what, it is not the same. In fact, you know, the alternate might be true, but we don't say that we are going to accept the alternate. Remember that we say that from the sample, for the sample that we have, we're going to reject the idea that the mean school value for A and B are the same, okay, in the context, okay. So we say that meaning at the 5% significance level, there is sufficient evidence that to reject the idea, the claim that the mean school value added for school A and school B are equal or the same, either way, okay. So I am not going to say that we are going to accept it. It is incorrect to say that, meaning accepting the alternate. Indirectly, that's what we're saying, but, you know, statistically speaking, strictly speaking, when we say we are, you know, when we're making use of this phrase that, you know, at the 5% significance level, you know, the very fact that, you know, you're making such statements that, you know, at the 5%, because if you change the significance level, you could have had a different kind of a result, right? 0.02, 0.05, you could have had something else based on a larger sample. So based on the sample, we have sufficient evidence to reject that claim that they are equal. We are not saying that they may not be equal, or, you know, that we are not saying that, how do I say that? Okay, we are rejecting the claim that they are equal. That means we are implying that they're not equal, but they may be equal. You know, if the sample size was different, and if the significance level was different. Okay, so just based on the sample, based on the significance level, we have sufficient data to reject that claim, the null claim. All right, the last part. Let's just do this, and so that the question 1 is done. All right, use Augustine's results. Or using Augustine's results, explain how each school could claim they are performing better than the other school. Oh, okay, school A and school B, using Augustine's results. So what has Augustine proved? I think in this particular hypothesis test from H part 2, you know, since we've rejected the null here, I think school A can say, because school A is better off, right? In this case, they can say that we have a better school value added. You know, we have a better school value added. That's what school A can say. We are doing better than school B in terms of school value added. But in the earlier test meaning when we did this pull-to test here, and this was about the mean final exam result. You know, the mean final exam result, and there again in that test, if you recall, we rejected the null, and which meant that the alternate hypothesis about the school B was better off in the mean final exam. That's how each school can boast. Let me see if I can recall all that and write it down. Maybe I'll just write it down here, okay? Maybe this is not the place. Maybe I should write it down here. Let me just put a line, and maybe put a line here. This is H part 2, and what is this? This I. All right, so this is question number 1, and this is the I, and said school A can claim that they have a better or higher mean school value added than school B. All right, that is from H part, if you want, you can write that thing also down from H part 2. And school B can claim that they have a better or a higher mean, what's that, exam result? Let me just go back and check that right word. Mean final exam result. Okay, mean final exam result. Better write that, mean final exam result than school A. And this was from, I don't know, I forgot. This is E part 2. Yeah, E part 2. Yeah. So I just write that thing also. And I'm lost. Where is that? Literally. From E part 2. I think that's it. Okay, so basically how each one can boast about their in what way they're doing better. School A can claim that they have a better mean school value added, and school B can say that they have a better mean final exam result. Okay, that completes question number 1 for this particular paper. In the next video, of course, we are going to solve question number 2. If you found anything useful in this particular video, please make sure that you like and share this video with your friend and subscribe to my channel. All right, please go and visit my channel. There are several videos there, go and check them out. And if you want any topic, any question, any paper solved, do mention that in the comments and I will make a video for you.